question 12. So for point 1, we've got to find the equation of L2 which passes through P, 8, 3, and is perpendicular to the line L1. So L1, 3x minus y equals 1. Now if we rearrange that, we get y equaling 3x minus 1. So the gradient of L1 is 3. Now if that's the gradient of L1, the gradient of L2, given that it's perpendicular, flip it over and change the sign, must be minus a third. So using the formula y minus y1 equals mx minus x1, we know the gradient is minus a third, and we know a point on the line is 8, 3. So substituting that in, we get y minus 3 equals minus a third x minus 8. Now in order to undo this minusing a third, I've chosen to multiply through by minus 3, giving me minus 3y plus 9 equals x minus 8. And then adding 3y and adding 8 to both sides, I get x plus 3y equals 17. Now for part 2, I've got to find the coordinates of the point Q where L1 and L2 intersect. Now L1 is y equals 3x minus 1, and L2 is x plus 3y equals 17. So if we substitute 1 into 2, I get x plus 3 lots of 3x minus y equals 17, and following through the algebra, that gives me x being 2. Substituting that back into one of the straight lines, say 3x minus 1, I get the y coordinate being 5. So the coordinate of Q is 2, 5. Now for part 3, I've got to find the length of PQ. So a quick sketch just to help us gather our thoughts. Q is at 2, 5, P is at 8, 3. So just using Pythagoras, we've got the x length being from 2 to 8, which is 6. The y length being from 3 to 5, which is 2. So PQ squared equals 2 squared plus 6 squared, which is 40. So PQ is the square root of 40. Now for part 4, write down the equation of the circle that has centre P and line L1 as a tangent. Now I think a good sketch here really helps us answer both part 4 and part 5. So we're told that it has centre P, which we know is 8, 3. We're told that it has L1 as a tangent. So if L1 is a tangent, then L2 must be the radius, must be providing the radius. Okay, L2 must be the straight line, because if that's a tangent and then at 90 degrees, L2 must be giving us the radius here. So Q is 2, 5, P is 8, 3. We know that Q must be on the actual circle itself because we get L1 and L2 being perpendicular to each other. Excuse me. Right, I think there's yeah. So therefore we've got a centre at 8, 3, and we've got a radius of obviously being the length PQ squared. Okay, so remember the equation of a circle is x minus 8 all squared plus y minus 3 all squared equals the radius squared. So the radius squared is 40 because PQ was root 40. Now for part 5, write down the equation of the other line that is a tangent to the circle and is parallel to line L1. So let's think about it. When we were going from P to Q, we were going 6 to the left and 2 up. So if we're going to P to R, we must be going 2 down and 6 to the right. So that's going to be giving us 2 down from, so 6 to the right will give us an x coordinate of 14, and 2 down will give us a y coordinate of 1. So we know that R, which is another tangent to the circle with the same gradient, has coordinate 14, 1. Clearly this tangent will have the same slope as L1, so it has a gradient of 3. So again, using y minus y1 equals mx minus x1, I only get y minus 1 equals 3 lots of x minus 14. Multiplying out and rearranging, I get 3x minus y equals 41.